All right, we are working on page 45 in our note packet, and it is a lesson on triangle similarity. So we are focusing on these three similarities: angle, angle, side, 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 and side, angle, side. And so this might look a little confusing because we also did congruent triangles, and side, 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 and side, angle, side were part of being congruent triangles. I want to remind you that these are not congruent sides. When we talk about sides for similarity, they have to be proportional. Okay, so the angles have to be the same, the sides have to be proportional. So I want to just make a note, anytime we're talking about sides, maybe we should write the word sides there. Anytime we're talking about sides in similarity, it's not about being the same, it's about them being proportional. Okay, so that's sort of my big sidebar. Now we're going to start off with two warm-ups. So go ahead and take a look at number 1 and number 2. This is old news. So they're telling us their triangles are similar, and they want us to find the missing side or angle. Okay, so first let's match this up. We have the same angles, and that was one of the things. There's two rules. The angles have to be the same. So if these two are the same, then the third angle must be the same, left over from 180. So we have similar triangles, and if we go to put these together, I would put the 4 over x, and that was one of the issues, is making sure you're matching it up. Of these two sides, 4 is the short side, x is the short side, and then come back to your first triangle, 8 over 5. Now, we could have set it up differently, but we should get the same cross products if we had the right proportions. So 4 times 5 is 20, x times 8 is 8x, and so divide both sides by 8, and x equals 2.5. So you want to have your calculators out and ready. We are going to use them some today. All right, so go ahead and look at number 2. Now we know nothing about the sides, but we do know some information about angles. So remember, we know they're similar. And so in number 2, I know that there's always 180 degrees in a triangle. So if you look at this, both of these are 90, and angle Y is congruent to angle C. So if C is 62 degrees, then Y is 62 degrees. And if there's 180 degrees in a triangle, I can now find x. 180 minus the 62 we transferred minus the 90. So grab your calculator or your brain, and we would find out that that angle x is 28 degrees. Now that would also mean that angle B is 28 degrees, because 180 minus 90 minus 62, and that is your leftover. Okay. So those are just some quick warm-ups. Let's talk about our similar polygons again. So for polygons to be similar, the corresponding angles have to be congruent. So angles have to be congruent, same rules we've been using, and the corresponding sides have to be proportional. So we need those two checks. So corresponding angles are congruent, so the angles have to match up, and the corresponding sides have to be proportional. So same decimal when we divide those ratios. Okay, now we're going to jump back a minute. We're going to get away from similarity, and we're going to talk about congruence. So when we talk about congruence, we cannot have the donkey. We cannot have SSA, as in, donkey. So whenever we look at this, our congruencies that we used were angle, side, 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 and side, angle, side. Now, there was one more, and it was hypotenuse, leg that we used. And I feel like there was one other one that I'm not thinking of. But if we focus on these congruencies, this is when the angles were congruent and the sides were congruent. So if we look at number 3, we're going to use some of these ideas today. If you look at number 3, I can actually prove these are congruent two ways. One, this is an equilateral triangle, and each piece is set equal. So I can say these are congruent by side, side, side. But there's another way I can do it, something we can mark because we know it's true. Do you see something else that we would mark normally? Yeah, exactly. Do you remember what these are called? These are those vertical angles, or we call them opposite angles. So absolutely. So knowing that, we could also use side, angle, side on this one. So I don't have to do this both ways, but I wanted to bring up the vertical angles. So do you see the side, included angle, side? Okay, now look at number 4. I have 2 angles. Is there anything else I can know about? Is there anything else I know about here that you could mark that's a fact? No one has anything? They share a side. Remember we put an X on here and that was the reflexive property? Do you remember that? So guys, this would be angle, side, angle. It has to be an included side. So angle, side, angle. And that's what makes those congruent. Okay, how about number 5? So now that we've just talked about this, these share a side. So anytime they share a side, it's congruent to itself. And you see the included angle. Side, angle, side. Side, angle, side. Okay, so those were triangle congruencies. We have congruent sides, we have congruent angles, and it has to be the appropriate grouping. So we're going to talk about the postulates that we have that are making triangles similar. All right, so go ahead, flip it over, and let's chat about it. So the first one is angle, angle. You don't get to use angle, angle when you're talking about congruent triangles, because remember, my triangle on my paper has congruent angles to the one up on the board or the one on your screen, but they're not the same size. So angle, angle proves similarity. So here it is. If two angles of one triangle, boom and boom, are congruent to two angles of another, then the triangles are similar. Okay, and here's the other thing. There's only 180 degrees, so you only have to know 2 of the angles because the third one would be congruent to the other one. All right, so these triangles, let me write my triangle similarity statement. Triangle ABC would be similar, not congruent, similar, and start again. A went with D, B went with E, and then F. And why are these similar? By angle, angle. Okay, now, the quick review is we have to have congruent angles marked to assume they're congruent. So you can't just look at it and say, oh, well, it looks congruent. You have to have the proper markings on it. So that was the quick reminder there. All right, now, side, side, side. Again, this is similar. So they're not going to be congruent. So 3 sides of one triangle are proportional to 3 sides of the other. So here's the deal. There's really no way to mark these. You know, before we would look for the matching tick marks, we can't do that. What we have to do is set up our proportions like we've been doing. So we would look and say, okay, AB over ED, or DE, would have to be equal to BC over EF, which would have to be equal to AE over DF. So that's what we would have to do. What should it be? Oh, AC. Good thing you're here. All right, is that better? Yeah. AC, oh, I think I went there. And then DF. So these have to be all equal ratios. We could just divide them down and see. And then we have congruent or similar triangles again. So triangle ABC is again similar to triangle EF. And that is by side, side, side. So this side, side, side is talking about proportions, not congruent sides. Okay, last one, side, angle, side. Now, this angle is still that included angle. So when I say side, angle, side, it says if 2 sides of one triangle has to be AB with BC is similar to 2 sides of another triangle. So I cannot use AC in this mix because it has to be an included angle. It has to be between these, okay? Now, if the angles are congruent, I get one congruent angle, and it's included, that's one check. And then the other check would be the proportion. AB over DE would have to equal BC over EF. So I would just need to be able to prove these two are proportional, and that's included. So then we have that same triangle similarity statement. Triangle ABC is similar to triangle DEF, and that is by side, angle, side. Okay, so we have a quick check to make sure we understand the included angle. So name the included angle. Okay, so find XW right here. Find WV right here. What angle is included between these sides? W up there, right? So angle W is the included angle. And you see that both of them had a W on their segment. Okay, so let's get into these practicing, okay? So if you look at the examples and we pay attention to the directions, which postulate makes the triangle similar, and then write the similarity statement, and then you're supposed to show work. Like, we have to prove this. So let me get in here a little tighter and focus. Okay, that's much better. Maybe I should have focused it earlier. So here's what I need to do. I need one of the similarity statements. So guys, we can be using angle, angle, we can use side, 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 or we can use side, angle, side, okay? Any of these three will work. So I know nothing about the sides. Do you agree with that? So I can't use side, 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 or side, angle, side. I can't just assume, so we have to prove two angles are congruent. So they both have 90. Out of 180 degrees, what's left here? 180 minus 90 minus 43. So type that in your calculators. What's angle C? This is where you'd have your calculators out, you know, useful. We should get, I hope, 47 degrees. Do we agree with that? Okay. Guys, that's enough right here. Do you see this angle, 90, and then do you see your 47 matches with 47? So by angle, angle, these are similar by angle, angle. Now, if you wanted to double check yourself, find angle D. Take 180 minus 47 minus 90. That's 43 degrees. So all three angles are similar. Now, don't forget, we want the triangle similarity statement. So triangle, I'll just go with ABC. Now let's match this up properly. So A is 43 degrees. It goes with D. And then B was 90. It goes with E and then F. But it might not be alphabetically. All right, so those are the two things we need, and finding the angles is my work. Okay, so we have agreed that we have vertical angles here. Now, that's all I know. I know one set of angles, so I cannot use angle, angle. I cannot use side, side, side because I don't know anything about these sides. So it comes down to this. I cannot just assume it's side, angle, side. Got it? I've got the angle. I need to prove the proportion. So when you go to look at this, don't match up anything. 12 on this triangle is the short side compared to the 2. So 12 should go with the short side of 16. So if you can think about this as being stapled down and then take this and spin it around there. And then come back to the first triangle, 15, the longer side would go with 20. So you could do the cross products and see if they're equal, but since we've been consistent with checking multiple proportions, just divide this down or reduce your fraction. They should both be 0.75 or 3/4. So that means that the sides that we needed are proportional. So these triangles are similar by side, angle, side. Side, included angle, side. Triangle congruence. Triangle TUX is similar. Now, I just randomly named that, but T goes with V, U goes with W, and then obviously X goes with X. And there you go. So let's flip it over. Now, we had to make a little edit because number 8 was cut off. So if you didn't get that written down, make sure you fix number 8. So I just redid the triangle down here. I can tell you that I don't know any angles, right? What were my ones? Angle, angle, side, 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 or side, angle, side. These are my similarity statements I can pick from. I don't know any angles, so I can't use anything with an angle. I've got to prove it by sides. So look at the little triangle. The smallest side is 6. The smallest side on the big triangle is 12. The middle side is 8. The middle side is 16. The long side is 10. The long side is 20. Okay, so take a minute, toss these in the calculators to get me that decimal, but I think some of you might see it. Aren't they all a half or 0.5? Yeah. So we can prove that these are similar by side, side, side. So similar by side, side, side. My triangle congruence, triangle DEF, is similar to triangle, okay, D. Now this takes me a little more effort. I went DE, which is the middle side, so I'm going to go with KJ. No, JK. JK. And then I went E to F, which is the longest side, which would be K to L. So that's why I'm putting the L there. That took me a little more effort because I didn't have anything else marked. Okay, so let's look at number 9. Now, we're stepping it up a notch on number 9. We're bringing back parallel lines. Okay, in number 9, the first thing I noticed was right here, okay, vertical angles. So honestly, with that, I can prove with proportions, we can do 2 things here. So without worrying about the parallel lines, I can show that 9 is bigger, right? So I'm going to go 9 with 27, and that should equal 7 with 21. Okay, so divide this in your calculator or reduce it. They're both 1/3. So the sides are congruent. So I can prove these are similar by side angle side. So that's one way I can do it. And we'll come up with the congruence in a second. But what I need you guys to see is something that's going to come up that we might need if we weren't given the sides. Can you see these parallel lines right here? And how do I know they're parallel? Because they have these markings. Okay, we had a similar figure on this page right here. We had the same idea, but it wasn't marked that these were parallel, so we don't know that they were. But these are marked parallel. And then do you guys remember that transversal? We spent a lot of time on this. So if you can ignore this extra line and just look at blue, you have parallel lines marked by transversal. Do you remember those alternate interior angles? Anybody remember that? Alternate interior angles? Those were congruent. And we have another transversal, if you will, and it also has alternate interior angles. So I could also prove this triangle is similar by angle, angle. Okay? I didn't need to prove both ways, but there's going to be a time where maybe you don't have the number. So parallel lines are important. We use that. Okay, triangle similarity. Triangle UVW is similar. Okay, now U goes with Y, and then V went with X, and W goes with W. Okay, so I'm going to have you guys try number 10 and 11. So go ahead, pause this video, try 10 and 11. Okay, so looking at number 10, it's a little bit different. They don't give us any of the angles, so that's an issue. And they don't give us anything about sides other than, I know it doesn't look that way, but this is supposed to be an equilateral triangle, right? All 3 sides are equal, and all 3 sides are equal. Now, these are not congruent, but guys, if all 3 of these are equal, and I say these are all 10, and these are all 5, wouldn't 10 divided by 5 each time be the same proportion? So I know it's a little bit different. We can't mathematically prove it, but if these are all the same, they would all divide by the same number. So these are similar by side, side, side. So it actually took me a lot less effort. I don't have to do any of the algebra. And that would be that triangle ABC, I'm going to go around this way, triangle ABC is similar to triangle FGH. Okay? So that's it. That's all I had to do there. Now, look at number 11. We know nothing about the sides. So when you're picking your one of them, it's going to have to be all angles. I have no information on sides, but I don't have congruent angles other than the 52. So what you should have done is just take a quick minute, find angle A, 180 minus 52 minus 81. What's left over for that? 47? Do you agree with me? Okay, well, that's good news because we also have a 47 over here. So this angle is congruent. And if we take away 180 minus the 52 minus the 47, we'll get 81. So all 3 angles are congruent. I only needed 2. So this is similar by angle, angle. Triangle ABC is similar to triangle. Okay, I went A to B. Now, what did A match up with? It did match up with F, right? So triangle FGH. Okay, so the next thing we're doing is we're going to tell why the triangles are similar and then find the missing value. So the missing value is not an issue. You guys are really good at that. We just want to practice saying why they're similar. So looking at example 12, we're supposed to find B, and B is right here. I know it doesn't look like a variable. So looking at this, we have 3 sets of sides, but I can't use side, side, side for the Y because I don't know that side. Got it? But you guys have been telling me about these vertical angles. So I can say these are similar by side angle side after I prove the sides are proportional. Okay, so the short of these two is 12, and that goes over the short of these two is 16, and that equals 15 over 20. Okay, so go ahead and divide down. We should get 0.75 or 3/4. So I'm content that these are similar by side angle side. So now that I know they're similar, I can find B. So here's what I want to do. The 6 goes with B. I need that, and I only need one other proportion, so I'm just going to do the 12 and 16. So here's where you guys need to be careful. If I'm looking for B, I obviously need to put that in a proportion and then pick one other set. So I don't need this to solve it. Okay, cross multiply. 6 times 16 is 96 equals B times 12, or 12B. Divide by 12. What's B equal? It is 8. Okay, so that's all I needed to do. Tell why they are similar with some proof and solve for the unknown. All right, so look at number 13 now. And we have two triangles. I do know information about sides. I do know some information about angles. So how can I prove these are similar? Well, if you try to do something with sides, I don't know all three sides. So I can't do side, side, side. And I only know two sides, but I don't know all the information. So I cannot use side, angle, side. I also can't use it because the angle is not included. So I have to use angle, angle. And do you see we have it? Two angles. So it's similar by angle, angle. And then I just need to find x. So I don't need to find the angles, but I could. So I'm going with the 4 over 10. That's the hypotenuse, right? And that equals 6 over x. So be consistent. 4x equals 6 times 10. And divide by 4. What's x equal? 15. There you go. Oops. Probably better if I was writing on the screen. Okay, so I'm going to pause this, and I want you to try 14 and 15. Okay, so I'm going to pause this. You guys pause this at home first. Okay, number 14, there's a lot going on here. There's something that I don't know if you guys picked up on. If you can look at these two lines, they're not marked parallel, but I can tell you they are parallel. So look at these two lines cut by this transversal. These are corresponding angles. Remember that transversal cutting through the parallel lines. These are corresponding angles. And if corresponding angles are congruent, then I have parallel lines. So if I have parallel lines, and you think about this being a transversal, I have these two angles are congruent also. So if you are having trouble proving that these were similar, I can prove they're similar by angle, angle. But I had to know that little trick of corresponding angles telling me they're parallel, and then knowing that these are also corresponding. Okay, so I can't use the sides. Now, here's the other issue. A lot of you probably set up a proportion and you did something like 10 over x equals 8 over 12. And I hate to be the bearer of bad news, but that's no good. Look at the little, did you add 10 and x? So let me show you this. Let me show you this little triangle in purple here. Okay, the little triangle is 10 and 18. R, S, and V. I'm taking the time on this because I think it's important. And then the big triangle, let me get something to scribble on. What is it? 18. Oh, good call. Oh, because my little number there. Okay, that's 8. I was just checking to make sure you guys are paying attention. Do you like that? All right, and then this guy, the big one, the big triangle, which I don't think I drew to scale, it's RTU. That's 12. What's this? It's 10 plus x. That's what catches you. Look, this piece here is 10. This piece here is x. So the whole side of the big triangle is 10 plus x. And I'm telling you, that will get you all the time. So that's why I wanted to take the time to show this. And I think separating the triangles might help. So when you go to do it, I have a feeling a lot of us have to fix this proportion. So when I go to do the obvious one, 8 over 12, that's easy, right? You're not going to mess that one up. But a lot of people probably did equals 10 over x. But it's really equals 10 over what? The little over the whole thing, 10 plus x. Yeah. So do you see it now? 10 over 10 plus x, 8 over 12. That's a tricky one. Okay, well, now that we've got that out of the way, we've practiced this a lot. It's going to be not just 8 times 10, but 8 times 10 plus x equals 12 times 10. So 80 plus 8x equals 120. All right, subtract 80 from both sides. We get 8x equals what, 40? Divide both sides by 8, and what do we get? I'm hoping we get 5. Okay, so definitely a tricky one, something to make note of. That gets people all the time. Now, look at number 15. First of all, I have these vertical angles are congruent, but we have an issue. I can't use side angle side because I don't know this side. So I do need those parallel lines, right? Parallel lines cut by a transversal, so this angle is congruent to that angle. They're alternate interior, or we could do the reverse. But that's all I needed were two angles. So I can prove these are also similar by angle, angle. And so now I need to find that missing side. So 36, and this gets spun around if you're looking at it. See how this angle's up here? So 36 would go over 54, and then come back here. 54 would go over x. And it's a little confusing because you have those two 54s. All right, cross multiply. 36x equals 2916. Double check my number there. Do we agree? Okay. What did you think it was? Okay, well, if I do 36 over this 54, then I came back to 54 over x. So you could reverse the setup, but we have to have the same cross products. All right, so what does x equal? 81. 81, you're good. All right.